This is TechCrunch. The scourge of modern concrete is, perhaps surprisingly, rust. Most concrete structures are laced with steel rebar to add strength, but if the metal corrodes, it can cause the concrete to fail prematurely. Bridges, which are exposed to water and salt, are some of the most vulnerable. About one-third of bridges in the U.S. need to be repaired or replaced, which could cost nearly $400 billion over the next decade. Now, there are plenty of ways engineers cope with rust, from coating the rebar with epoxy to pouring extra concrete to buy some time before seeping water reaches the rebar. Eventually, though, those measures fail, and the only way to truly prevent problematic rust is to use stainless steel rebar, which is not cheap. It's too expensive to be used in every bridge, so cities and states will only turn to it for the most critical spans. But Allium is proposing a compromise of sorts by covering regular rebar with a thin layer of stainless steel to prolong the intended life of a bridge from 30 to 100 years. Samuel McAlpine, co-founder and CTO at Allium, said, "As long as we're getting full coverage of the surface, a thin layer is enough stainless steel to where it's going to resist corrosion for hundreds or thousands of years." Allium told TechCrunch exclusively that the startup's stainless steel layered rebar was recently used in a bridge deck replacement on U.S. Highway 101 in California, and another is planned for Interstate 91 in Massachusetts. It also contributed to a commercial boatyard in Key West, Florida. For critical bridges that carry lots of traffic, engineers sometimes specify stainless steel, which costs around 5 times more than regular rebar. Governments consider the added costs are worth it if they don't have to shut down a major artery. But for most other bridges, they tend to specify epoxy-coated rebar, which is only about 25 to 50% more than uncoated rebar. Epoxy-coated rebar needs to be housed in covered storage, and any welded spots or nicks in the coating need to be patched, both of which add additional indirect costs. Allium is pitching its stainless-clad rebar as a replacement for epoxy-coated. The company aims to match the price of epoxy coating and possibly undercut it in the future. When installed, Allium's rebar should cost less because it doesn't need to be handled as carefully. The startup's rebar also won't need additional concrete, that is, sometimes added to bridges to forestall rusting. This extra layer of concrete is not structural, it's just meant to try to insulate the rebar and delay how long it takes for the salt to get to the rebar. Eliminating that could trim cement use by up to 20%, and because the rebar isn't as susceptible to corrosion, it should allow transportation departments to specify the use of greener cements, which tend to be less alkaline than standard mixes. Allium's process clads 7,000-pound billets of steel with a layer of stainless steel, essentially welding wires to the exterior until it's fully coated. That billet, which is typically between 6 to 8 inches square and 40 feet long, is then fed through a series of rollers until it reaches the desired thickness, which ranges from about 1/3 of an inch to a couple of inches in diameter. By cladding a smaller surface area with a thicker layer and integrating into the mill's process, well, the company can do something that's a lot cheaper, a lot more scalable, a lot easier to control the quality of. As the billet is getting thinned out, growing up to 150 times longer in the process, the stainless steel does as well. Ultimately, each piece of rebar ends up with about 0.2 of a millimeter of stainless cladding. McAlpine said that even with that small amount, you're not going to corrode through that stainless steel in concrete. That's it from TechCrunch. For more tech stories like this one, go to TechCrunch.com.